All right, so you're looking at gradients under coordinate geometry. We want to calculate the gradient of a straight line and given two pairs of coordinates. Usually one coordinate, right, we would label as x1, y1, the other as x2, y2, right? And basically when we're talking about the gradient, we're talking about the slope of a line, right? We're talking about how steep or how flat that particular line is. On the graph, we talk about it as the vertical rise, right, versus the horizontal run. And the formula for calculating is here. I would have included it here. You must know this formula. Gradient, which is usually denoted by the letter m, is equal to y2 minus y1 over x2 minus x1, right? And this is how we're going to calculate the gradient of any line if we have 2 points on that line, right? Any 2 points. It doesn't need to be the end points. Any 2 points, we can use this formula to calculate it. So let's look at an example of doing this. Right? I'm going to put on the side here. Let's get 2 points. So I'm just going to randomly label 2 points here. Let's say 5, 6. Let's say B, 3, 8. Right? So if you want to find the gradient given the 2 points above lie on the same line. Right? We need 2 points that are on the same line. It's important to have 2 points that's on the same line. That's how we're going to be able to determine the gradient. So each point, we want to take each point and we're setting it to x1, y1. Remember this, right? And x2, y2. Any point, it doesn't matter. Right? So I'm going to label this one x1, this one y1. Right? You have to be consistent in your labeling. So the ones together, the twos together. And then simply a formula, put your formula, m is equal to y2 minus y1 over x2 minus x1. Right? Y2 is going to be 8, as you can see here. Y1 is going to be 6. X2 is going to be 3, and x1 is going to be 5. Right? Normal rules of algebra would apply here in terms of your signs. So 8 subtract 2 is going to give me, 8 subtract 6 is going to give me 2, a jump in the gun. And 3 take away minus 5 is going to give me minus 2. 2 over minus 2 is going to give me minus 1. All right, and this is how you're going to calculate the gradient of any line. So important, right? What we need to remember, right, is we must be able to identify 2 points on a line in order to calculate the gradient. The other way we can look at the gradient is if we are given the equation of the line. Let's say we're given the equation of the line in the in this particular format. Right? The coefficient of x is always your gradient, right? So y is equal to m. This is the general form of a straight line. Y is equal to mx plus c, where m is your gradient, right? So those are the two ways in which it is we can see the we can identify the gradient for a straight line. Either we are actually calculating it, and if we are calculating, we must have 2 points on that line, or we have the equation of the line and we can read, we must write it in the form y is equal to mx plus c, and we are looking for the number or the coefficient of x in order to determine what that gradient is. Now, important for us to know as well too is parallel lines and perpendicular lines. They have a relationship that we can identify them by based on the gradient. And I've kind of highlighted it here. Just take off this bit. Right? two lines are parallel if they have the same gradient, and two lines are perpendicular if the product of the gradients is equal to -1. Right? For the products to be equal to -1, what will happen is basically the gradients are reciprocal of each other, meaning that if one line has a gradient of 5, then in order for another line to be perpendicular to it, the gradient of that other line is going to be -1/5, right? We flip it and we change the sign. If we multiply the two of them by each other, right? So I'll show you an example here. Y is equal to 5x plus 1. And let's say y is equal to -1/5 x plus 3. If we just take the gradients, right? We could call this one equation 1. We could call this one equation 2, right? Gradient for equation 1 is 5, and the gradient for equation 2 is -1/5. Right? So we could say M1 is equal to 5 as the gradient for equation 1. M2 is equal to -1/5. The rule is saying that the product of the gradients here must be -1. See now? Product of the gradients. So if I take M1 and I multiply it by M2, I should get -1. Let's check that and see if that happens. All right? If we take 5, I'll just really working on the side here and multiply that by -1/5. What's going to happen there? This would cancel, and we get an answer of -1. So these two lines is a good example of two lines that are perpendicular to each other because the product of their gradients is equal to -1, right? And the only way you'd be able to get that -1 between the product of two numbers is by multiplying the number by its reciprocal. Reciprocal means that you are flipping the number. If it's a whole number, it becomes a fraction, and you're also changing that sign. All right, that makes sense? You okay with that?
Yes, sir. Yes, sir.
The parallel lines are a lot easier to identify because with the parallel lines, the gradients pretty much are the same. So one line might be given as y is equal to 2x minus 3, while another line might be y is equal to 2x plus 40, right? Different equations, but they are parallel, right? They'll be running same distance apart, right, in the same direction because they're parallel lines. And we can identify that because the gradients are the same, right? Same gradients. So I had two examples here, apart from the ones that I just gave. Right? So we have a line y is equal to 5x minus 3. And they want us to write down the gradient of the line that is parallel to this. So parallel to this, right, a line parallel to y is equal to 5x minus 3 will have a gradient of 5. Right? It'll be the same because the rule says that parallel lines have same gradients, right? And B, a line that is perpendicular to y is equal to 5x minus 3 will have gradient of what we said when we looking at the gradient of a perpendicular line. We need the reciprocal of that gradient, right? So we're gonna get negative because this is positive, and we flip it, it'll be 1/5. All right. So far we talk about gradients. We identify how we are finding the gradients using the formula, right? And the formula to calculate the gradient is given here. M is equal to y2 minus y1 over x2 minus x1. The vertical rise over the horizontal run, right? We also talked about looking at the general form of the equation, y is equal to mx plus c, and we said that coefficient of x is the gradient, so we could read it off from the equation of a line, but it must be in a general form. And the same thing goes as well too for what we just talked about with the parallel and perpendicular lines, right? What do I mean by that? If I have, or if I am given something like this, 2y plus x is equal to 3, right? This is not in a general form of the equation of a line. We have to rewrite this first, right? We must rewrite this first in order to read off the gradient. So what we'll have to do is make y the subject of the formula by moving this x across here and also moving this 2, right? We'll have to divide throughout by 2. If you divide x by 2, what we'll get is a half. Right, all right, it like this so now. Right, only when we do this, plus sign here. Right, so I could pull the 1 from on top here and put it as a half. Now we could look at this gradient here and we could talk about a line that is parallel to it, a line that's perpendicular to it. It must be in that form. We could even identify the gradient here as being negative a half. Right, before when it was like this, if we said the gradient was 1 because in front of x is a 1, we will be incorrect because this is not the general form for the equation of a line. It must be in the form y is equal to mx plus c. All right, you okay with that? So that's all we need to know in terms of the gradient of a line. Right, next we want to talk about finding the midpoint of a line and the length of a line. Right, when we find the midpoint of a line and the length of a line, basically again we need 2 points, but unlike the gradient, which could be any 2 points, in order to find the midpoint and the length of the line, we need the end points of the line. It would make sense, right? Because if you want to get the length of the line, we just can't take any random values on the line. We must have the start and the end. Similarly, if you're trying to find the midpoint of the line, we have to find the middle, right, which is in between the start and the end. So in questions like this, if it's a worded question, they would tell you that a straight line passes through these particular points, so the endpoints of the line JK is such and such, or they might actually give you a graph and you have to read off the graph your endpoint, starting point and your ending point. It doesn't matter if you which side you use, right? The formula would adjust accordingly, right? So here I have a question where J is 6 and minus 2 and K is minus 5 and 3, right? So we have x1, y1, always label your points, x2, y2. Now we're not doing 1, 2, 1, 2, because then you're going to get wrong, right? The first point is the first point, so the x's and y's there is labeled with 1. The second point is the second point, so the x's and y's there are labeled with 2's. After we do this, it's always good to quote your formula. Right, we want to distinguish between gradient and midpoint, so I'm actually abbreviating the word midpoint. And the formula for midpoint is the halfway point between the two x coordinates and the halfway point between the two y coordinates. Right, x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Right, so our x1 is 6, our x2 is minus 5 has been divided by 2. our y1 is -2, and our y2 is 3. Right? And that's the importance of labeling the points x1 and y1, so you don't mix things up on write things in the wrong places and then you make mistakes like that. So then we working these out, right? So what we will get here, we get 6 minus 5 divided by 2. Up here we get -2 plus 3. I could work this out immediately. This will give me 1. Right? This will also give me 1. So the midpoint of this line is actually a half and a half. Right? A half and a half. That's the midpoint of the line. Let's look at the length of the line as well. And this one, we basically finding the square root in the difference of our x value squared and our y value squared. Now, if we look at the proof of this, we would realize that essentially what we're doing here is Pythagoras theorem, but sometimes I do like to show the overlap because students tend to get a bit confused, right? So just know the formula. The formula is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. All right. And again, once you have a formula, when you're practicing and you're doing these questions, always write the formula. That's going to help reinforce what the formula is. So always start by writing the formula. It's also going to help eliminate any errors as well, because now you're just doing substitution. Our x2 value is -5. Our x1 value is 6. Our y2 value is 3. And our y1 value is -2. Right, -11 here, all squared. We're going to get here 3 plus 2. Always do your brackets first, yes? 121 plus 5 squared. 121 plus 25. So 146. I have my calculator first one. Not. Right, the square root of 146, you could write this to like 2 decimal places, and the answer is always in units. 12.08 units is the measurement that you're going to use here for coordinate geometry. Right, so that's our midpoint and our length of the line. So you're okay with that, right? You understand how to find the midpoint and the length of the line? Yeah? Right, so formulas is the most important thing, right? Especially here for coordinate geometry. Need to know these to find a midpoint. This is what you're doing. To find the length of the line, this is what you're doing. Right? We have two with examples showing us how we actually are using or applying these formulas in order to find the midpoint and the length of the line. All right. So I'm moving on now. I'm going to move on. I'm going to look at equation of a straight line. Now, I mentioned before that the general form for the equation of a straight line is usually y is equal to mx x plus c, right? Where m is the gradient, right? X and y are coordinates. And the term c is what we call a constant. So x and y, they assume different values. They're variables, right? And the value of y is based on x, right? Because as we change x, y changes. That's why we have a formula there. Y is equal to mx plus c, right? So we're going to look at two cases here. The first case is where we actually given 2 points on the line, right? If we are given 2 points on the line, our approach to finding the equation on the line is a bit different to case 2, which you'd see below. Let's get the spotlight. So this is case 1 here, right? You're given 2 points. So my approach to finding the equation of a line when given 2 points is going to be a bit different to my approach if I am given the gradient and the point on the line. Actually, I have a little less work to do when I am already given the gradient, right? If I'm not given the gradient and I'm given 2 points, I am required to actually go find that gradient first and then find the equation of the line. All right, so let's look at that. So we have 2 points, right? We have 2 points, L is equal to 4 and 6, and M is equal to 6 and 10. As always, label. Right? So the steps when it is we are given 2 points in order to find the equation in line. The first step is we have to find the gradient. Right? We must find the gradient before we actually get to find the equation of the line. Because most importantly, we need to know what the gradient is, right? Before we could even find out what c is. X and y is fine because I mean, look, we have a x and we have a y here. We could simply just plug in 4 as a x and 6 as a y, right? And if we know our gradient, we could find the c value. But we don't know the gradient, so we can't get to this general form of the equation in line until we actually know what the gradient is. And we know that our formula to find the gradient is equal to y2 minus y1 all over x2 minus x1, right? And we label these above, and with good reason. So now we're just going to substitute here. Y2 is 10, y1 is 6, right? X2 is 6, x1 is 4. 10 take away 6 is going to give me 4. 6 take away 4 is going to give me 2. Our gradient 4 over 2 is going to give me 2. Step 2 now. Use equation of line formula. And one of the points. Right? I deliberately included that last bit there and one of the points so that you know that you need the gradient which you just calculated, which is 2. We need a point, so let's just take say in A, it's not A. Let's take the point L. And why am I taking this point? I'm taking this point because L is going to give me my x and y coordinates, right? And this is the equation of the line here. Y is equal to mx plus c. So we could do some substitution at this point, right? Y is 6, m is 2, x is 4, and now we could find c, right? So 6 is equal to 2 4s are 8 plus C, right? And then I want to make C the subject of the formula, right? So I'm going to move that 8 away from that C. 6 minus 8 is going to give me minus 2. Now you don't stop here, right? A lot of students tend to stop here, but this is not the answer. You need to actually write the equation now, but you're not putting in values for X and Y, right? Because those are variables. Where you're going to put the values in is for the gradient and the constant. And the constant is going to be whatever value you got for C. So it may be positive, it may be negative, right? And this is how we're going to find the equation of a line, right? This is the equation of the line LM is y is equal to 2x minus 2. All right? You okay with that?
Yes, sir.
All right, nice. So the next case now, which I said was a simpler case, is for obvious reasons, we're given the gradient, we know how to calculate the gradient, right? So we could actually start from here with y is equal, c is equal to 4 and 3, they gave us this, right? The gradient m is equal to 3 and 4. So we're already at step 2, right? So y is equal to mx plus c. C is giving us our x and y coordinates. Y is 3, m is 3/4, and x is 4 plus c, right? If I multiply here, my 4's will cancel. I'll remain with 3, right? I move the 3 across, I'm going to get 0. So here, the equation is going to be y is equal to m is 3/4 x, and well, I don't need to put plus 0, right? Because 0 doesn't hold any value there. So I could actually just leave it like that. Right? So the equation of my line, when C is 4, 3, and my gradient is 3/4, is y is equal to 3/4 x, right? Or 3 and 4x. And those are the two cases where two types of questions you can get where you need to find the equation of a line. All right, are you okay with that so far? So almost to,
Yes,
the,
sir.
to the point where you're going to do some questions to me. You just have one more piece of content to look at here. And this is the x and y intercepts of a straight line. Big words. X-intercept and y-intercept. What do they mean? Right? The y-intercept, we could start with the y-intercept, or the x-intercept. I always like to tell students the x-intercept occurs where y is equal to 0. And the y-intercept occurs where x is equal to 0, right? So they're opposites. And if you just remember these two phrases, then you will never have any problems in finding the y and the x-intercepts. Now let's look at it on the graph, right? On the graph that I have here, this is the line y is equal to 4/5 x plus 5, right? So if we plot this graph, this is what we're going to get. We said the x-intercept, looking at this one first, occurs where y is 0. Now, where's my y-axis? This is my y-axis here. Right? And values for y would be like these values here, right? This is 10 on the y-axis, 9 on the y-axis, 8 on the y-axis, 7 on the y-axis, 6 on the y-axis, 5 on the y-axis, and so on and so forth, right? So my question to you is, where is y is equal to 0? So if I said all of these are different points on the x-axis, and I'm asking where y is equal to 0, well, 0 is going to be right here, right? Between 1 and -1. This is where y is equal to 0. And I want you to look left to right. When that happens, you're looking for the point at which the line is actually cutting that x-axis, because the x-axis the x-axis is where y is equal to 0. Right? I remember my maths teacher used to make us write, when we have to label the axis, we have to write y is equal x-axis, and in next to it with a semicolon, we put y is equal to 0. And for the y-axis next to it, we will always write x is equal to 0. And that was to help us to remember that on this line, this y-axis here, on this line y-axis, x is 0 throughout this line. So any point on this line is always going to have 0 for the x coordinate, and then whatever value y holds. At the bottom here on the x-axis, right, any point on this line is always going to have a coordinate of 0 for the y value, right? Does that make sense to you? Any point that lies on the x-axis is passing through y is equal to 0. Any point that is on the y-axis, the coordinate of the x is passing through the point x is equal to 0. So when we talk about the x-intercept and the y-intercept, we are looking for points where the line cuts either your x-axis or your y-axis. Right, so maybe I could include that here as well. Right, so y is equal to 0 happens at the x-axis, and x is equal to 0 happens at the y-axis. So we are looking for points on the x-axis, points on x-axis, right? We're looking for points on the y-axis when we're talking about the y-intercept, right? So you see y-intercept, label it here, y-intercept. It is a point on our y-axis. It is 5, right? And if the y is 5, the x is going to be 0, because on this line, x is always equal to 0. On this line, y is always equal to 0. Does that make sense to you?
Yes.
Right? Now, how do we find this outside of the graph or when we're looking at the equation of a line? So here's an example. If we have y is equal to 2x plus 4, and I want my x-intercept, I let y be equal to 0, right? So if this is the equation here and I'm trying to find my x-intercept, I set y to be 0, and then I find out what value x will be when y is equal to 0 by solving for x, right? Just move everything across the equal sign. X is going to be 0. X is going to be minus 2, right? So the answer here will be x is minus 2 and y is 0. This is my x-intercept, right? For my y-intercept, using the same equation, right? If I'm using the same equation to find my y-intercept, I have to let, and it's always easier to find the y-intercept, and I'll show you why. If we take the equation here and we let x be 0, what happens? Then this whole thing here becomes 0, and then y is just equal to 4, right? So x is 0 and y is equal to 4, and that happens to be the constant. So for the y-intercept, right, we say y is equal to c. Whatever the equation of the line is, y is always going to be equal to c, because if we set x to be 0, then that entire middle piece here, let's get more annotating, guys. If we put this to be 0, then this whole thing here going to be 0, and y is just going to be equal to whatever the value of c is, right? So that's our x-intercepts and y-intercepts. Now it could be a bit confusing, so you just want to look over this afterwards. I've recorded the session so you could do so. Now is where you're going to get a bit of practice with what we just looked at. So I have a few questions here, just 4 questions, right? This is what you're going to work on for me now. Quadrilateral ABC is formed by joining the points whose coordinates are A, right? That's a letter O there. They didn't no letter O, sorry, that should be a 0. Calculate length of AC, right? So ignore, I think this is our typo, it should be the letter, the number 0, sorry, same letter. And that's a 0, right? A is -20, B is 0, 4, C is 7, 3, and D is equal to 3 minus 5.
Yes, sir.
Right? Show that BD is perpendicular to AC. Remember what we said about perpendicular lines? The gradients are the reciprocal. Part C, we don't really test this on the syllabus anymore, but we could still take a look at it. Right? 2, the coordinates A and B are 3, 5, and 7, 1 respectively. X is the midpoint of AB. Calculate the length of AB, the gradient of AB, and the coordinates of the midpoint. Determine the equation of the perpendicular bisector of AB and state the coordinates of the point at which the perpendicular bisector meets the y-axis. Right, so I want you to do A for me. Right, B we will do together. Let me correct it. Number 3, the straight line HK cuts the y-axis at 0, -1. Right, what happens at the y-axis? The y-axis is where x is 0. Right, this is our y-intercept we're talking about here. Right, y-intercept is when x is 0. The gradient of HK is 2, 3. Show that the equation of the line HK is this. Now notice that they didn't write this in the form y is equal to mx plus c. I want you first to find it in that form y is equal to mx plus c. And then you can always, more than likely, you're going to have to divide by a particular number to get rid of a fraction to get it back to this, right? So work out what here you're finding the equation of the line for me. Right, and the last one, the coordinates of A and B are 5, 24, and -10 and 12 respectively. Calculate the gradient of the line joining A, B, right? Very straightforward, just gradient of the finding out for number 4. So those are the 4 questions you're going to look at. Remember, for part B here, we're doing this together, right? A, B, and C should be fine. Number 3, you're finding the equation of the line. Number 4, you're finding the gradient. All right? So you're going to work on that for me now.